Some lovely presentation. So while you guys are eating, let's hear about what everybody did this year. Take it away, mechanical food.
I guess the first thing we added some.
You're gonna have to speak a lot louder than that.
First thing we added some presenters. So I guess we'll introduce ourselves.
Hi guys, I'm Peter, better known as Double Click.
I'm Peter. I'm Patrick.
What?
We can do that. I'm Nathan.
I'm David. All right, so our build season, right? It began off with us planning. So we would go up to a classroom up in Northeastern, and then we'd sit down, and for 2 days straight, we would just like hash out what ideas what we want our robot to do. So we would like, we would go see the game and the actual game, and then we're gonna find out, oh, our robot's gonna do this and that, and then from that we would like finally like optimize like how we want to score. Like this year we wanted to score as many cubes as possible, and so yeah, so we want from that we would then want like a robot that would score as many cubes as possible.
Yeah, so a critical part of this is optimizing. Sorry, my voice isn't dialed in yet. The critical part of this is optimizing like how we want to play the game, not necessarily what the robot does or how the robot does that, but more how we want to play the game. And then after that, we split into groups to start working on different systems to figure out what's the optimal way to do each like individual component of the game. So we've got some pictures. Okay. So then the next step in the process is prototyping. So we try and, so every game is different and we don't really have a idea of what we have ideas. We don't know the best way to do everything at the start of the season. So we just start building stuff. Usually it's just out of wood, although we've done a lot of later cut parts and 3D print parts this year, which was useful for rapid prototyping. And we just try and build as much stuff as we can to see what works and what doesn't. And once we have a sense of what works, we start refining our prototypes a little bit.
Yeah, there was a video with it, I guess.
Oh, geez. So that's one of our original intakes, well, maybe generation 3 intakes. And that ended up being very similar to what went on our robot, but we built like 4 of those to test different shapes of where all the wheels sat in relation to each other.
All right, so the way we designed our robot, the way we started our prototyping, was through computer-aided design or CAD. So what program we use was SolidWorks, of course. We get our own licenses for students to download the software onto their own laptops or the computers inside the lab. And it's the software, like, it's not just for students and things like that. It's like software that real engineers use, like in real life, like building things in their like company or for like military things like that. It allows us to work out like everything, see like geometry issues, like a lot of like math problems, things like that, so we know how everything works together. And also what we can use is when we make new parts, we can export it to our 3D printer, and we can 3D print models of it, so we can see how they look, and how they work in real life.
All right, yeah. So we make most of our metal parts we do in-house on either our CNC or our lathe. And for those parents who don't know this, a CNC is it's kind of like a drill, but it cuts sideways, and it's computer driven. So it'll cut out shapes and plates of metal. And then other parts we 3D print on. We have a couple printers that we use. One of them is actually upstairs here. Yeah, so that's a video of the CNC cutting. It's very slow, as you can see. That was actually part of our drive plates for the practice spot. And then after we're done making the parts, we powder coat everything. So it's like painting, but you use an electrically charged spray gun to shoot powder onto the metal plate, which then sticks there, and then you cook it in an oven to make it harden. It's a little bit more easy than painting. And then we get our nice pretty parts, and then we stick everything together.
Yeah, and that's our final, well, not final, but it's our robot by the end of the build season.
And then we go compete.
Yeah.
Excellent. Who's next? You're off the
All right. Hi guys. I'm Brian. You guys know me. I'm Josh. I'm Chris. And we're the software team. Yeah. So let's start off. So this year we have accomplished a lot, more, especially in our preseason. The team as a whole has started with this new Ftc program where the entire team split up into groups and construct their own Ftc robots, which are smaller scale competitive robots that we use for training. So as the programming team, we had to kind of split up into each of the teams to help them program, which also helped teach a lot of newer students.
So during the preseason, we undertook a thing called motion profiling. So basically what that is it allows us to like drive more smooth on the field and like basically do repeatable things on the field so we can like wind up in the same place every time. And that really works well for us during autonomous because we want to be in the same place every time in autonomous so we know where we're scoring and we can like tune it out. And we really use that a lot during our season.
We had also trained several new students. Some other programming students had taken on freshman programming students or other new programming students on their own and had taught them the basics of programming so that they could learn the build season. And then speaking of said build season, as we get into that, we've constructed a complete robot code base on WPI-lib, based on WPI-lib in Java. So we programmed a drivetrain, the elevator, the intake, and our double lift system, which we'll get into later. And then again, motion profiling, we talked about earlier, trying to use motion profiling to autonomously return to set positions on the field. And then with that, we also constructed a scouting app. We'll rehash a previously used scouting app in order to efficiently organize and intake data at competitions. So, yeah.
Starting off, we talked about the FTC season and kind of what it's about. So what we do is with FTC, we started as like a precursor for new students to be able to jump into a program where they're able to really start programming and learning about things from day one. So starting off, we broke off into 7 different teams, and each team had their own like group of kids, different, and all starting from new students to older students, depending on which team that you're on. The Ftc Control System was a little bit different than FRC. It's based on the Android like you have Android phones that are used for the control system, and you're using Android Studio and Java to program these smaller scale robots that compete in a smaller game. The build season for FTC is significantly shorter. We had a shorter time period. I think it's the same 4 or 5 weeks roughly. And as a whole, our team competed in 1 competition, and then we just moved on from there into our actual FRC season. And yeah, that's really it. We had all of the robots compete at the competition that we went to, and it got a lot of kids to be able to get used to the environment of how competitions run and what we're able to do at those events.
So moving on the FRC program, which is what the team focuses on, during the build season, we decided early on that we're going to move away from what we did last year. Last year we did a custom framework thing, which allowed us to do a couple more little things, but there was a lot of issues with that we encountered last year. So we moved towards back to standard WPI-lib, which is what First sends out, like basically makes to like allow other teams to make robots, and that allowed us to do command-based programming, which allowed us to like implement many different things. So like the way command-based programming works is you make a command code, and that's basically like something the robot does, like tell the elevator to go to a certain position. So this allowed us like allowed us to basically like bring together different parts of the robot, the different subsystems like the drivetrain, elevator, and intake, and basically like make an entire robot functional. So as a team, as a software team, we did this all through collaborating through GitHub, which is basically which basically allowed us to manage code bases and like make different branches for different testing and different features, and we use that a lot.
And this also allowed our great mentors like Kelly and Kyle, you guys like raise your hands. It allowed us to have them help us out and review our code and let us know what we're doing wrong and make sure we weren't pushing anything when we weren't supposed to and making a lot of mistakes. So thank you guys for helping us with that and reviewing our code. Using that platform.
So we focused on 4 different subsystems during the season. These are the main parts of the robot. And starting off, we have the drivetrain. So basically what the drivetrain is it basically allows us to drive across the field and get the different parts. So basically the wheels. And with the drivetrain, we implemented motion profiling to allow us, like I said before, during autonomous, go to a certain place in the field repeatedly. And the cool thing about the motion profiling we did, we allowed different automatic and saving techniques and loading techniques to basically make it faster and not have to make the profiles every time the robot started up.
Yeah, and then moving on with the intake. So we had a simple 1-button control system for the intake to intake one of the power cubes in. And then we did that via a proximity sensor, which was found within like that kind of base in the back of the intake. So once that cube was sensed, the intakes would run automatically, and you could just suck in a cube and it would have it clamp onto the elevator and already be in a certain position. So we try to make that as seamless as possible within the entire system of the robot, so you can make sure we cycle out cubes as fast as possible throughout the night.
So it was all automatic. Yeah. We really want to make a lot of automatic stuff during the season, so we implemented a lot of stuff like that, such as in our elevator. Similar to the drivetrain, we also implemented a motion profiling type of thing called CTREs, Motion Magic. And what CTRE is the company that basically sends us motion controllers to control motors at different speeds in certain ways. So that allowed us to basically set points on the elevator. So like there was a switch set point, which was a scoring. So different scoring zones, we had different set points, and all the operator had to do was press a button and it would automatically run there. So it wasn't a lot of like crazy, like I had to go up and down, up and down. There was also like small fine tuning things you could do too.
Yeah, and then lastly, you also have the double lift, which is our climbing system to latch on to the climbing bar and then also pick up another robot with us. So yeah, we had a 2-button process, one going up and then one dropping that, like releasing the locks on that double lift to drop it down and lift up another robot. And yeah, a lot of it was really mechanical and it involved a lot of pneumatics in there, but we were able to control the way we lift faster, slow, and stuff. So it was really nice.
So talking about motion profiling one more time, this is kind of what it looks like on the input side of things. So for example, I'm not sure if you see this image too well, but we basically had different types of positions, different heights on the elevator that basically allowed us to press one button. So like when we intook a cube, it would automatically lift the drive height using that motion profiling thing. And that was really cool. And basically the way motion profiling works, it takes like the elevator and like how its speed and how it is in its position, and it basically uses math to basically like give the motor's input to get to the certain place, and it ramps and slows down. And for driving, we basically told the robot to go to different points and orientations, and that's how those motion profiling.
We can undergo this all autonomously. So with all our achievements within the year, we had some small hiccups along the road, which is all part of the process. So sometimes when we were testing, we weren't exactly the most careful. So that led to things like some of the code cables breaking, pulley stripping, one 360-degree full send. We had damage to scale in our first match, but yeah, we did accomplish some to Cubatas through that process. But this is more so to highlight the kind of tribulations we faced throughout the entire process. So yeah, it wasn't exactly that smooth of a process, but we made sure we made it work, and it ended up being a really successful control base that we constructed for the entire robot, and it led us to have a lot of success for the entire season. But again, that success didn't come with its own hiccups. So yeah.
Okay. So what our future plan for not only developing a more cohesive and better software for year in, year on. We wanted to continue working on our motion profiling because this year we had our own little hiccups with using it, and we didn't perfect our profiles. It was really just we were getting to learn how the actual process worked and how we were able to actually use motion profiles to move across the field and be able to move to precise points and be able to, like, instead of wasting time trying to figure things out in concrete tasks, we were able to actually move and cohesively do things. And in the fall, we just want to create a better program for newer students to not only come in and work with students to be able to code from day one and keep kids engaged and not only staying through like the programming program. And then working with, we have, I believe last year had gotten a NVIDIA Jetson, which is a board used for like computing and like vision, what was the?
So basically, the NVIDIA Jetson is like a small microcomputer, a larger microcomputer that basically has a has the graphics card on it and a bunch of things, and we're still experimenting it and like learning exactly what it is. And we plan to do that more during the summer and kind of like learn what we can do with it. And one idea we have with it right now is to do advanced computer vision, so we can like basically like get target data faster.
Yeah, that's up. And then we're also working on more efficient logging. So one thing that we encountered through a lot of testing this year was trying to figure out how far we're going and where exactly, if we found a hiccup while testing, for example, that motion profiling, we wanted more specific data on what was happening, what was going wrong, step by step by step. So going into the next season, since we're going to be continuing to use motion profiling, we want to work on having an efficient logging system where we can see printouts of every single rotation that those wheels make along the way, so we can see where it messed up and where it kind of went off path there. So when we work with, in the future, we're going to be working on implementing a more efficient logging system that won't use up too much of the onboard memory that we have on the robot's computer there. So yeah, that's just one of our future plans there. And yeah, that's it for us. Yeah.
Cool.
All right. Electrical. You at?
All right, hello everybody. My name is Kirsten.
And I'm Harris.
And we're going to be talking about the electrical sub-team's work throughout the season. All right, so where do we begin? We usually have the mechanical sub-team working on the CAD model, which allows us to be a little bit unproductive the first week, which also allows us to try new things during that first week or two. So when we finally get the CAD model, we want to get understanding of what the robot is supposed to do. What are the mechanisms and how it's supposed to operate. So from that understanding, we have to think, what do we need? And based on all these electrical components, this allows us to think which things are going to be used. For example, in the 2016 year of Steamworks, we did not use the PCM, the pneumatic control module, at all. It didn't seem necessary, so we didn't use it. However, for this year, for Power Up, we actually use a lot more pneumatics than we usually do. So that was something we additionally had to put into our electrical system. So after that, we have the idea of understanding what we need. We need to brainstorm ideas depending on what we want. So that brings us to deciding on which layouts to do.
The type of layout, there's three types where first one is removable electronics. And some of the pros are where you can take it out and electrical can work on their board as mechanical works on their stuff. But some of the bad things can lead to, well, messy wiring, some incorrect wiring. Like you just put it back in and then just everyone just connects things and then everything can go wrong since things just aren't connected correctly. There's a stacked layout, which just basically, as the name says, it's a stacked layout. So there's different ways of like having top and bottom. Usually you'll have more horizontal space because there's just more like space to work on. And another bad thing with this one is, as well, as it can get messy since there's not really like a way to work, or at least there's not enough space for people to work on.
Yeah, it's also very difficult to reach some certain electrical components. So stack layout can sometimes be a little not the best when it comes to reaching to certain things.
And then there's belly pan, which is really, really great. It's usually one of the most popular options that people use. electronics on the same level, everything can be neat, clean, but sometimes there's not enough, like people aren't really careful of space and then things can just get out of whack.
Yeah. Especially when it came to our robot this year, we definitely worked with a minimal amount of space throughout the year. So it seemed very difficult to work around it. So it allowed us to do some type of prototyping, which is just a generalization of what we think the electrical layout will technically be. And so we definitely always go for the belly pan because it allows us to look through and see what things, so it's like a good way to have everything accessible to us. And so here we're just doing wiring stuff. There's one of our prototype robots that we worked on. And pretty much this is not the best picture to look at, but one of the ones I found. And pretty much this is the basic layout of what we decided to have it as. So we usually have the battery in the middle, and there's our PDP, or the power distribution panel, which is like one of the main electronic components. And for the pneumatic tubing, we had more additional tubes in there. So this was actually moved towards, towards the back end of the robot. And it pretty much kind of decreased the amount of space we had to work around it, but it worked out in the end. So yeah, thank you.
All right, non-tech. Non-tech, where you at?
Stay on like the first session. We're not going to be reading through it. We're just speaking, okay? We're not clicking through it, okay? We're not clicking through it. Everyone else can next. I don't know what you guys think. No, it doesn't look fine. They look through it. Okay. All right, so we're the non-tech group. My name is Justin.
My name's Amen.
I'm Kirsten again. I'm Gabby.
My name is Mike.
Okay, I'm sorry. They're clowns. So we're the group of students on the team that focus on outreach, communicating with other teams, and communicating with First overall. So what we try to do is we do the chairman's essay, which is a award given by First. I'm so sorry. And we also do the community outreach with the team. We focus on that type of thing, and they can all add on to that.
Okay, so yeah, this pretty much allows us the opportunity to think of all of our outreach events and how we can bring it together to present to judges throughout the season. And it's a great way to pretty much represent ourselves and have other people see us as like a certain role model. So it's a great way to like demonstrate ourselves in the best way possible.
It also just helps us network with other teams and getting into bigger things like the Compass Alliance and that also.
Excellent. No. All right, so this year our chairman's theme revolved around scientists that best represented our team values and morals. Scientists like Dean Kamen and Marie Curie, and
we try to focus more on like female scientists, and then Dean came along. So we wanted to have like, based on the qualities of each scientist, we thought these best represent what our team values the most. And so we just have many different scientists like Rosalind Yallow, Mae Jemison. So we just want to have like a good spread of diversity, which expresses who we are.
It took us a long time to get to this idea. So we went through a lot of data mining, looking through last year's submission, seeing the points that we can take, the good and the bad. And then we continued to look through resources, stuff like that, try to find a theme that would best fit what we wanted to shoot for this year, especially seeing how last year it did work out, but in some ways more than others. So, yeah.
And going off of this, when we do talk about our chairman's chairman's like part of the team, we have the people who write the essay, like Gabby and Mikey over there. They're writers of the essay, and they can elaborate on what it's like to write the essay and the executive summaries.
So at first, that whole thing is like bad. Like when you first get into it, it's just like trying to get all of our information into everything is really complicated, and especially since me and Mikey were originally like just two of us last year, which has helped a lot that there's more people and expanding out this year since there's more eyes on the essay rather than us stressing out over it. And it was like really hectic trying to figure out how to put all of this together, and being like our first year on the team. And it's just like the whole process takes a lot. We begin from the summer and try to collect everything like Eamon and Christine and Justin said, to collect the data from last year. And we really focus a lot on supersizing, like 31, 32 told us to. And I think that helped us a lot to get how far we did this year. And I really hope that it helps us more progress on into getting a better presentation and overall essay.
Yeah, last year was like first year, like a lot of pressure on us to like get the essay done, and like what we learned from last year is like be more prepared, and like we learned that since we like went to Worlds, we didn't like win Worlds, we went all the way to Worlds for chairmans. We learned like we need to do more things to like more outreach so we can get like farther into maybe like win Worlds possibly.
And off the chairman's team, there's not only the people who write the essay, there's also the people who present our presentation. I was one of the presenters, so was my buddy here, Eamon, and so was Kirsten. We presented at, I forget the name.
The initial one was
North
Shore.
District champs and champs. We were not all of us were the presenters for each of that one. Kirsten missed district champs, and it was rough, but we all were able to work together. There's our backup presenter back there, Tatiana.
Raise your hand, Tatiana.
Oh yeah, Tatiana.
Wonderful presenter.
There we go. Tatiana!
She plans on being a future chairman's presenter, so you can't wait to see her for next year.
Yeah, so when we're talking about the presentations, it's a very stressful thing. You go in there, you don't know what you're gonna get. Sometimes you'll get some mean judges. Sometimes you'll get judges you've seen before.
Sometimes you'll get bowls falling on the floor.
Things happen. What she's referencing was year before, last year. Yeah, last year. We were presenting at World Championships, and outside of the doors of our presentation, a bunch of metal salad bowls fell. And you know, like how bowls fall, they make like boom. That went on for like a solid 15 seconds. I was in the middle of my lines. Never again. But I went on, I presented this year as well. So second year presenting. I feel pretty good about it.
No bowls.
No bowls this year. And yeah, and I'm sorry that we're not going through the slideshow, but to build off what they said earlier about the Compass Alliance, that is a collaborative platform. It's a big word. Collaborative platform that we were invited to help create with other teams from around the world. And what our plan is with that is to become the one-stop shop first, and be able to help teams, whether it be mechanically, non-technically, with anything they need on their team. If they have any questions, we want to make sure that we're there to be able to answer for all these questions that they have. Many of us did go to the meetings where we stayed, where we had video calls with the other teams about working on stuff. So yeah, it was a
Because of Compass Alliance, it also helped out with Here For You, which is the thing that Tati, Eamon, and Caitlin started, which is a mental, really? Oh.
which we'll later get into. And no, stop.
There's nothing there. Okay, so let's move on, and we'll see what our video had come to for chairman. Oh, is the volume on?
Is there sound?
Yeah, I think you gotta turn on the TV.
Okay.
Okay,
Where's the controllers?
Why they didn't slip through. Okay, are we good? Yeah, no?
Go.
It just comes from the laptop. Can people kind of hear it?
Does everyone be quiet?
It is the highest laptop boost.
It's not connected to the It's not.
Okay, wait. Technical difficulties. Take off the subtitles.
Yeah, really, just take them off.
Yeah, it's going through the computer.
Yeah.
Just
So.
play it.
Just play it.
Just play it.
All right,
Yeah.
come on. Just stay.
In the laptop.
One of my favorites is definitely being a part of the FLL competition, because back in high school I was an FLL student. I never realized how other people, like older than me at that time, were so willing to like help me learn and expand.
I was a lot more immature. I didn't know anything. I didn't know what I wanted to do. I had no idea what I was doing with my life. I was just like, listen, my parents are going to college and go be a doctor or something. Then I didn't really have a passion. Like, I was betting on so make money. But because I started neutrons, I found a passion like programming, data science, and like robot systems, and I really enjoy that.
My first year on the team, I would have said success would have meant just being on the field. A team where we are now, success for me is a much higher goal. Obviously, all that stuff is important, but I expect us to put 100% of ourselves into the team, the robot, our work submissions, our outreach, everything we do. And as long as we feel good at the end of the day about what came out of that and what went on the field, I think that's a successful year for us.
Came up with the idea and start finding programs to help. Without like our team, like social media, that's a big part of like getting everything across and to help and listen together, because obviously one team can't end it.
It's really amazing to see like the crowd of the teams actually involved. It's like this small idea of like two young teams.
Throughout all my years being on this team, I have grown from doing nothing to learning so much because of our upperclassmen that we had, and they were just like such great influences on my technical skills, and I wanted to strive to be as good as they were, if not better.
When I joined the Neutrons, I felt everyone part of this like family. I was going to have me everything to be a Neutron member, being someone willing to try new things and learn from work.
That's it. I'm so sorry.
What is that supposed to last?
No. I'm hearing from my source. Are you done? Yeah.
Amen. Right, so there's no more presentations, right? All right, well, it's on the folder. Well, come on, let's go. Come on.
Go get popcorn.
The dog. All right, we got one more. Let's listen up.
My name is Ayman. And we started Fairview along with another teammate of ours, Kaylin. She couldn't come today.
So Here For You is a collaborative project, and its purpose is to try to end the stigma around mental health.
Really put her out out here. Really, don't be afraid.
Just talk like me.
Just let it loose.
And try to spread awareness around the FIRST community. The Here For You is also integrated with the Compass Alliance, and we have launched 7 fire rooms in total so far. And we also use social media to try to keep in contact with other teams.
So quiet rooms are a safe place where people can go in case they're distressed or feel uneasy at competitions. So we offer coloring pages, stress balls, self-care sheets, stickers, and pamphlets, all to help them and help people out if they're feeling a bit off at competitions.
So some good things that happened in the room where we noticed that a lot of people used it, and a lot of people would try to contact us to try and get quiet rooms in their district. Some things that didn't work was there was a lack of supervision, and sometimes the quiet room was left unorganized.
So we use social media to help spread the word about Here For You in the FIRST community. We had a lot of pictures of our handouts and quiet rooms on Instagram, as well as we started a community page on Facebook. We sent out surveys so we can get info about how our quiet rooms work from people that actually use them, so we can better ourselves and better the program. And we also connected with other teams around the world and implemented it at various other FIRST competitions around the world.
Some of our future goals is to try to get recognized by FIRST, try to get quiet rooms at every competition, also to try to get professionals available at FIRST events, and to try to make mental health seen as important as safety is.
That's it.
Very nice. All right, that's it for presentations. But we have one more big event to take care of, which is the dismissing of the seniors. So, can I have all the seniors please join me up here? They're going to need some encouragement.
Stop.
Please, single file line.
Josh.
So here's what I'm going to have you guys do. Say who you are for the people who may not know who you are. Tell us how long you were on the team. Tell us what you're doing after you graduate. You graduated already, right? All of you? You're all done. Tell us what you're doing. And, of course, words of advice for the rest of the team as you move forward. So, Mr. Josh Young, please start us off.
I'm Josh Young. My name is Josh Young.
Listen loud. We can't hear you.
My name's Josh Young. I've been on the team for the last 2 years. After this year, I'm going to Northeastern University, and I plan to continue to mentor on the team. Words of advice. Rise up.
No, that doesn't count.
I guess something cliche, I guess I could say, is always believe in yourself and always try your hardest, and I guess always just try to strive for your goals, because if you try, you'll always land somewhere around your goals, and yeah, I don't know.
All right.
Hi, I'm Nathan. I've been on the team for 4 years after I graduate, or I already graduated, so I'm going to Northeastern also, and I'm going to try and continue to mentor the team. Words of
watch this either.
Yeah, words of advice. I guess ask questions. Mentors are amazing, and they'll answer your questions, and you can learn a lot from them.
Hi, I'm Peter. Double click. After the team, I'm gonna be heading to Boston College to study physics. Hopefully, thank you. Yeah, I'll tell all my fans. Hopefully, during that time, I'll be a part of the Big Brother program where I hang out with kids. Y'all are great. But one word of advice. Probably be yourself. Have fun while you're doing something, because if you don't have fun, then it's probably not your passion, and you're gonna be stuck with it for the rest of your life. This team. Oh, I've been on the team for 4 years too.
My name's Gaetano. I'm going to Wentworth next year.
What? So the camera can hear you.
My name's Gaetano. I'm going to Wentworth next year, and I've been on the team for 3 years. And some pieces of advice I have for all of you is to listen to what the mentors say, because they know what they're doing and they're trying to help you as best as they can.
Say hi to your mother. She's on the camera.
Use your words.
Hi, my name is Eamon. I've been on the team for this past year, and I graduated and I'm going to Wentworth. I'm studying computer science. I'm joining with Gaetano. Also,
oh my God.
One piece of advice I have for those that are still here. No, wait. Those here. Make friends. Try to talk if you're feeling off, things like that. And make friends, yeah.
Hello everyone, my name is Kirsten. I will also be attending Wentworth. This is my second year on the team. And I guess a piece of advice would be always try new things. If you see an opportunity, definitely go reach for it, because definitely something I kind of regret is saying I wish I have not done this, rather than saying something I kind of regret is saying I wish I'd done this rather than I wish I did not do this, because it allows you the opportunity to experience new things. So definitely reach out and try new things.
courtesy of Christine, so you can say thank you to her. We have some parting gifts. They are a customized superposition notebook for you to remain studious and learn from in your journeys. So, all right, let's give it up one more time for the seniors.
Let's all stand up here.
Take a bow.
No, I'm staying up. We're staying
Take a
up.
bow.
I thought we agreed on standing.
No, we're just sitting. The camera sit down.
Special group. Right
We can't.
So we've got some cake. We're gonna do all of that as that's going on. But before we do, I just want to say a few things. So obviously, this was another great year for our team. Another year where we did plenty of things that we set out to do that we've never done before, and managed to accomplish a lot of the goals that we set out. As we go forward, these people up here are leaving us. Many of these people in front of us took on major responsibilities for the team, which means the people that are still sitting down, it's up to you guys now to grab hold and push the team forward. This year is going to be really challenging for our team.
That's a horrible picture. Oh my God. Why is that there?
This year is going to be really challenging for our team, but it has the potential to be a unprecedented level of success for us. We're going to have a new lab space. We're going to have all sorts of new responsibilities, new work to accomplish. So it's up to everybody to carry that forward. What's that?
A couple new mentors.
Yeah, we got a few new mentors we're going to keep in line. So, as everyone knows, our season ends now. We are now into the next season, but we have a meeting on Tuesday, so we'll see everyone there. And that's how we do it. So, good job, everybody, this year. It was a lot of fun. I expect bigger things from us next year. I expect big things from our new mentors. Make sure you guys go out, bring your friends, recruit people that you think would be a good fit for the team. And how's the cake looking? Cake's looking good. So make sure you throw your dinner plates away and all that stuff. Take a few minutes, hang out, then we'll do some cake, and then we'll send this thing off.
Oh, and one last thing.
One last thing.
So we want to say a special thanks to a couple of our mentors. Here we are. So can we please have Brando, Henry, Christine, and Josh? Come on.
Come on, we're going to embarrass you. We're going to embarrass us. We made these for you.
Just all of us saying thank you very much, and we appreciate all you do.
Thank you. All right, so yeah, let's hang out for a few. We'll do some cake. And, good job.
So good. It was great because I just like slapped it on everything. Yeah. And actually, I'm glad you were doing it this year. Now that I have time to figure out what I SolidWorks build, and then
Okay, so last
It says Papa.
Oh, you did great, buddy.
They told me they had this presentation. I looked at it when I got here, and I was like, "You guys lied to me." Oh, like the presentation. Good. I need this.
I don't know.
So basically, what makes it like
have her over at a meeting tonight.
Yeah, but
Let them fail. This is a very controlled environment, so let them fail. You can put your presentation on that you did not read it. Better here.
you guys are made us take coffee.